Okay, so in this video we're going to look at something called reacting masses. Okay, this involves using a balanced simple equation and your knowledge of moles and mass to try and work through a problem to work out how much product you've got or how much reactant you need or various questions you might be asked. Okay, so the first thing you need is a balanced simple equation. Now generally in an exam this will be given to you. Okay, so but let's consider this reaction: magnesium reacts with oxygen to make magnesium oxide. Okay, just a quick bit of practice of balancing equations. Okay, to get this to balance, okay, we need to have a 2 there and a 2 there. Okay, so 2 magnesiums plus 1 oxygen molecule makes 2 magnesium oxide molecules. Okay, so we need this information in different points throughout this question, right? So here's how a question could be asked, right? Is how much magnesium oxide is produced from 60 grams of magnesium? Okay, so if I put 60 grams of magnesium into this reaction and it reacts with oxygen, I want to know, so I can work out before I do my experiment, what's the mass of magnesium oxide that I'm going to get. Okay, now this equation tells me that 2 magnesiums make 2 magnesium oxides, right? I can't just double that number because the relative masses of magnesium and magnesium oxide are different, and that's what's going to make this a bit more of a trickier calculation to work through. Okay, so similar to empirical formula calculations, I recommend you lay this out in a grid format. Okay, so we have the 2 things we're interested in is we're given information about magnesium and we want to know about the magnesium oxide. So one of the columns is magnesium and the other column is magnesium oxide. Okay, notice that the 2's in front we're not using at the moment, we'll come to them a bit later on. Okay, and then we're going to use our equation that we've been using in previous videos. Okay, number of moles, which equals mass divided by relative mass. Okay, you can rearrange that equation for mass equaling number of moles times by the relative mass. Okay, and then the last row is MR, relative mass. Okay, so before you start, put in all the information that you've been presented with in the question. Okay, so you've been told 60 grams of magnesium. Okay, so we don't need to do a calculation for this one. We can just stick a 60 in there. Okay, the relative masses we can work out because we've been given the formulas. Okay, so you need a periodic table to hand for this. And if you look up, the relative mass of magnesium is 24. Okay, again, notice we've ignored this 2 at this stage. We're going to use that later. It's just for a single particle. Okay, and then the last thing we can do before doing any calculations as such is the magnesium oxide. Again, get yourself a periodic table. Magnesium has a mass of 24. An oxygen atom has a relative mass of 16. Add them together and you get a relative mass of 40. Okay. Now the calculation that we can do within this grid is if we've got 3 things in each 3 rows. Okay. We need 2 bits of information in each column to be able to work out the 3rd. Okay. So we can't. This is ultimately the number we're trying to work out, the mass of magnesium oxide. But we can't do that at the moment because we don't know how many moles of magnesium oxide. We can, however, work out the number of moles of magnesium because we know the mass and we know the MR. Okay, so using this information here, mass is 60, relative mass is 24. So 60 divided by 24 equals 2.5. Okay, just to show you where those numbers have come from. Okay, so the mass is going there, the relative mass is going down there. Okay, so this tells us that if we've got 60 grams of magnesium oxide, then that's equivalent to having 2.5 moles worth of particles, magnesium particles. Okay. This is the point then now where we need to look back at the equation and to look at the numbers that are in front of each substance. Okay. And what this equation tells me is that 2 magnesiums react to make 2 magnesium oxides. Okay. So the ratio here is a 2 to 2 ratio, okay, which is actually the same as a 1 to 1 ratio. So for every 1 particle of magnesium, I make 1 particle of magnesium oxide. Okay, so the number of moles of magnesium oxide, okay, to get from here to here is that I'm timesing by 1. Okay, you don't have to write that. Okay, you can just write it over. Okay, so the number of moles of magnesium oxide is 2.5. Okay, so now I know the number of moles, I know the relative mass, so I can use my rearranged version of this equation to work out the mass. Okay, so it's number of moles, which is 2.5. Okay, MR is 40. Okay, you stick that into your calculator, and you get a value of 100. Okay, so to show you where the numbers have come from. So number of moles has come from there. Relative mass has come from there. Okay, and then this 100 is our fine mass. Okay, and now a trick for these, sometimes you'll be given these values in grams or kilograms or tons, whatever unit you were given it in the first place. So 60 grams, the units will be the same when you get over this side. Okay, so the answer then is 100 grams. Okay, so that's how you work through a reactant masses question when you're given the mass of one thing, a product or reactant, and you're asked to find out the amount of another thing within the equation. It could be another reactant, or it could be another product. Okay, so that's reactant masses. Done.